glad you could make it here today. We really appreciate it. We're going to talk about the technical collaboration on Windows 7 between Intel and Microsoft. There's no embargo, so you can write it at will. We're just keeping, handheld cameras, no big broadcast cameras. Our one camera there is from Intel. So no embargo, and let me just forward this. Our spokespeople today, both from Intel and Microsoft, we've got Steve Smith, who many of you already know, and Mike Swearingen, who's a program manager who works directly with Microsoft from the Intel side. On the Microsoft side, and where's this Mark right here? And then on the Microsoft side, we've got Mike and Julo. Mike, and really appreciate him coming down and talking with us. Also, Rustin Pennebaker. And we've also got Janet Argentine from Microsoft PR. So if you've got questions for Microsoft, she can help you. And we've got a number of Intel engineers who will be helping out with some of the demos, as well as Rustin, Beju, Vikas, Prashant, Daniel. You'll see them come up for certain demos. So if you have any questions for me, let me know. And without further ado, Steve Smith.
Okay, thanks, George, and welcome here today. We do want to make it interactive along the way, so as we go through each demo, we will have time for Q&A to make sure that we clarify what we're showing. I just want to start off by giving a little bit of perspective. You know, Intel and Microsoft have been working very closely together for well over 20 years. It's probably getting closer to 30 years now, given the age of the PC. And I want to give a little bit of a timeline to give you a perspective. If you look at a technology example like hyper-threading technology, we've been working together for approximately 15 years, coming up with the concepts of how our processors should be optimized for symmetric multiprocessing and symmetric multi-threading, and then Microsoft working on the complementary parts to optimize the operating system. And we work very closely as we bring our new product generations and the operating system to market. If I look at another example, virtualization technology, it's probably the better part of a decade that we've been working on virtualization technology. Intel brought it to market with our products beginning in the 2004 timeframe, and what you see in our current products is an even better optimization of hardware for virtualization technology, and you'll hear more about how Microsoft is using that to provide good advantage to the users in Windows 7. So today's focus is a little bit closer, shorter term, specifically on the optimizations for the Nehalem microarchitecture generation and the Windows 7 operating system, because those two were kind of contemporary in time. As we were working on the Nehalem microarchitecture, Microsoft was really turning on the development of Windows 7 in a big way. So we'll go through that in detail. I want to give you a little bit of perspective here on the platforms that we'll use to do these demonstrations. And I'll just walk through the room here. These are all based on our core microarchitecture. And I'll start off with the ones that are in production today. These are notebooks that happen to be Lenovo ThinkPads based on our Montevina technology with the Core 2 Duo processor, high volume mainstream notebook today. This is a desktop platform with the Core i7. It's our high-end platform that's been in production for some number of months right now, and is pretty well recognized as the unquestioned performance leader in the industry. But we're also going to show you that we're working to optimize on new platforms, starting with the soon-to-be-released Linfield processor, the P55 chipset on this demo. So with that one, we've actually, in terms of driving innovation, improved the hardware for hyper-threading technology. We've added other features such as turbo mode, such that if you don't have an application that is highly threaded, we actually can execute that lesser threaded application by stepping up the frequency of the cores and leaving the unused cores powered down. And then we have what we call power down technology on the core, where we actually switch off the power to the core when it's not being used. So those things enable the turbo mode here on Linfield. And then on the left side here, where we're going to be demonstrating some AES new instruction technology, we have our future 32 nanometer Westmere-based processors, configured in this case in desktop form. And those are to be in production from Intel in fourth quarter this year, fourth quarter 2009. And those are processors codenamed Clarkdale for the desktop and Arendelle for the notebook. Today we're going to be showing you the desktop variant of that platform. So, if you step back, takeaway is Windows 7 runs great, and we have co-optimized on today's mainstream and leadership platforms. And we have engaged to optimize even more to provide better benefit as we bring the new hardware platforms to market and as Microsoft brings Windows 7 to market soon. So with that, I want to turn it over to Mike Angiulo from Microsoft to give the perspective.
Thanks, Steve. So it's funny you mentioned the hyper-threading being at least 15 years old. I can remember, I've been at Microsoft 16 years, and one of the first projects I worked on was in Excel in the engineering team. At that point, John Devon, who now runs all of development for Windows, was dev manager of Excel, and it was there that we were working on Microsoft's first implementation of hyper-threading aware software. So the idea of taking an Excel model and being able to recalculate it on simultaneous threads was brand new thinking. This was back when a machine, we were thinking about a 4 megabyte RAM machine, not 4 gigabytes of RAM. And the difference that could make for people was important then. And so now I manage a team in Windows, the product planning and PC ecosystem team. I report to Steven Sinofsky, the president of Windows, and John Devon's now managing development in Windows. So here we are, 16 years later, still working very carefully with Intel to bring some of this technology to market in new and more powerful ways. What I like to talk about briefly are 3 of the important changes that were different in the way we built Windows 7 together with Intel. The first has to do with our engineering system. And our engineering system for Windows 7 on the Microsoft side was milestone-based. We hit a few very important engineering milestones by working together with Intel. For example, we hit our API complete release last October at PDC with the intention of giving software developers and driver developers a full year of a stable API platform before general availability. We hit our beta together in January, and the beta was done differently this time. Instead of in the past where we shipped a beta with lots of potential new ideas, we tried to ship a beta that was close enough to the final product to be worth measuring. And our new telemetry system gave us data that we never had before around where things were working or not working, where things were going slowly, where things were compatible or not out in the ecosystem. We have millions of users running that beta every single day. And when we sat down with Intel, we would go through that telemetry data together and use it to make and prioritize engineering decisions. And so that kind of infrastructure gave us more ability to know for sure that we were making systems that were going to be more performant and more secure, have longer battery life, and enable some of the new features that you're going to see here, like the virtualization. The other thing that we did for the first time was engage in multi-way partnerships between Microsoft, Intel, and some other partner. Maybe that other partner was an OEM, and we were working together to make sure that the drivers for a particular platform that OEM was going to ship were going to work well. Maybe it was a 3-way partnership with an ISP who's making, for example, security software, where they're very disk intensive, where we were working with them to make sure that when we're working together on higher performance disk work, like you're going to see here in a short period of time, that those disk-intensive applications like AV and indexing would take advantage of it. So we did those multi-way partnerships all with the intention that when these systems with Windows 7 start shipping on October 22nd, customers will see systems that have better end-to-end, all 4 of these. They're more energy efficient, there'll be security improvements that are enabled by both a combination of hardware and software. There'll be new features that end users can appreciate around virtualization that takes it from the data center to the desktop. And finally, the performance, or responsiveness, and overall performance of the system would be improved.